Hi, today we're going to learn about, today I'm going to do some common log problems. So in this section, I will go over some common log problems such as condensing and expanding logs. I will solve for x when the base isn't common, and finally, I will check for extraneous solutions. So these are some, a lot of common log problems that um, a lot of students get confused. Okay, so let's start with example one. It says write each logarithm in terms of ln of 2 and ln of 3. So they only want in terms of ln of 2 and ln of 3, nothing else. So in part A, we have ln of 6. How can I rewrite that as natural log of 2 and natural log of 3? So I know that if you multiply 2 and 3, you would get 6, right? So we can write this as ln of 2 times ln of 3, right? Because that will give us ln of 6. But if you recall that when you're dealing with logs or even natural logs, when you're multiplying logs or natural logs, you're really adding. So this is going to be ln of 2 plus ln of 3. And that's it. You can't go any further. And we have everything in natural log of 2 and natural log of 3. Okay, let's do B. So we have 2 over 27. So we got to somehow make that in a natural log of 2 and natural log of 3. Well, let's rewrite this. What do we know when we're dividing logs or dividing natural logs? Because natural logs and logs are pretty much the same family. So when you're dividing, you're really subtracting in the rule of logs. So you can rewrite this as ln of 2 minus ln of 27, right? Okay, now this is already an ln of 2, so we don't have to do anything with this. But this isn't in, we got to make it somehow an ln of 3, right? So what could I do? I know. Why not just change 27 in a common different base? So is there a base like something cubed will give you 27? Right, yes. 27 can be written as 3 to the third, right? And the reason why I do 3, because we need everything in common base of ln of 3, right? So let's do that. So that would be minus ln of 3 raised to the third power. Okay, and then over here we have ln of 2. Now, good, we're almost there. Now, we remember in the logs rule, if you have an exponent and when you're expanding it, you put the power in front of the log or natural log. So in our case, your final answer is going to be ln of 2 minus, and then this power goes in front of the natural log, so that's going to be minus 3 ln of 3. Okay. So here is your final answer. So let's do example 2. It says expand each logarithmic expression. So when they say expand, it literally means make it bigger. So let's see here. What do we know? When there's this squished together, so what I mean when they expand is we're going to have at least different log base of 4s. And notice that when they're really squished together, they're multiplying, right? When everything's squished together, it's multiplying. So we have a multiplication, and then multiplication, what do we know? Yeah, multiplication. What do we know about multiplying exponents? Logs, you're really adding, right? So let's rewrite this problem as, let's give everyone a single base of log 4. So log base 4, and then we'll start with the 5. So that would be 5 plus, right? Because we are timesing, and when we're timesing, we're adding. So plus log base of 4 of x3, and then plus, because we're going to times it by the y, plus log base 4 of y. Okay. Now, is this completely expanded? Not quite. What do we have? We have this x3, right? So when you're expanding log and you have a power, you put the power in front of the log. So this is going to be plus 3 log base 4 of x, and then bring down the rest. So now this is the most expanded form of your log form. Let's move on to B. So we got to expand this natural log, making it bigger, but you can rewrite this problem using only exponents. Some people prefer that, so let me do that. I can rewrite this problem as ln parentheses and then radical 3x minus 5, believe it or not, that can be written as 3x minus 5 raised to the 1/2, right? Because anything raised to the 1/2, like x to the 1/2, is the same thing as square root of x. So I'm going to rewrite this as 3x on the numerator, 3x minus 5 parentheses raised to the 1/2, and then it's all over 7. Okay, so now what do we know? We have division. We have a division and we have a power. And what do we know about division when dealing with logs when you're expanding? Division is equivalent to subtraction. So when you're dividing logs, you're really subtracting. So let me rewrite this. So let me fix the numerator expanding. So it'd be ln parentheses 3x minus 5 raised to the 1/2. And then we have a division dividing by ln of 7. So it's going to be a minus because dividing means subtracting. Ln of 7. Okay, almost there. Is this completely expanded? Not quite, because we have a power of 1/2, and then the power always goes in front of the log or natural log when expanding. So it's going to be 1/2 ln of 3x minus 5 minus ln of 7. So this is now completely expanded. Okay, now we're like example 3, it says condensed, meaning making it smaller. So we're kind of like going backwards. We have something expanded, now we got to make it smaller, condensed it. So it says condense each logarithmic expression. Okay, so what do we know? Well, let's just do it one by one. So remember, if you have a number in front of a log, that is technically a power, right? So let me rewrite that first. So this thing here becomes log base 10 of x, and then this is a power, so it's raised to the 1/2. And then let's do the same thing with this. There's a 3 in front of log, so that means we have a power of 3, correct? So that would be plus log base 10 of x plus 1 raised to the 3rd power. Okay, so is it completely condensed? No, because we want it into one single log base 10. So the only way we have to do one step further. If you want, you can rewrite log base x of 1/2 into, that's the equivalent to saying log base 10 of square root of x, right? Because anything raised to the 1/2 is like square root of x plus log base 10 of x plus 1 raised to the 3rd power. Okay, almost there. We're just going to make it to one single log base 10. So what do we know about addition? Well, in the log rules, when you're adding logs, you're really multiplying. So we can write this as one single log base 10. So your final answer is going to be log base 10. And then we're just going to multiply, because we are adding, we're going to multiply. So we're going to multiply the square root of x and the x plus 3 raised to the 3rd power. So that's going to be log base 10 and then parentheses square root of x, parentheses x plus 1 raised to the cubed, and then close it with another parentheses. So yes, this should be your final answer. Okay, let's do letter B. We got to condense it, making it smaller. So first thing is, let's do the power. So there's a 2 in front of this ln, so that we know that automatically is a power. So you can rewrite this as ln of x plus 2 raised to the second power minus ln of x. Okay, and then I think we could just do one more last step, because what do we know about minusing logs? You're really dividing. So we can write this as your final answer as a single ln parentheses x plus 2 square. And then this minus represents division, so it's going to be all over x. And that is it. That's your final answer in condensing. Okay, let's do example 4. It says, in example 4, it says solve each equation and round to 3. Solve each equation, meaning solve for x, and round to 3 decimal places. Okay, so we want to solve for x, and we got to round to 3 decimal places. And the reason why we got to do 3 decimal places is because, okay, well, first off, when you look, let's start with A. We have 4 raised to the x equals 72. Now, usually you should try to get, what you can do is try to get everything in the common base. But there's no way this will work. There's no such thing. There's no common base that'll give you evenly. So what I mean is, like, the 2, with the 4, you can rewrite that. You can rewrite 4 as 2 to the second power raised to the x power, right? But you can't do that with the 72, right? There's no number, if you put it in the calc, there's no number raised to the x gives you 72, right? So when you can't put everything in the common base, what you're going to do is to take the log of both sides. Take the log or natural log. I prefer logs. So over here we have an x. So remember, when you're expanding log, you put it in front of the log, the power in front of the log. So it's going to be x times log, and then we're just going to do log of 4 equals, this is not log base of 4, this is just log 4. And then do this, take the log on the right side, so that'd be log of 72. Okay, almost there. Just now we got to solve for x, so we have to get rid of this log 4. So the only way we could do that is divide both sides by log 4. Divide by log 4. Okay, so you get x equals log of 72 over log of 4. Now you could put this in exactly like in the calculator, and you should get 3.08496. And they say round to 3 decimal places. So here's 1, 2, 3. Here's the third place. The neighbor is 9, which is greater than 5. So you're going to round. So your final answer is going to be 3.085. There you go. That is your final answer. Okay, let's do the same thing with B. There's no way we can get everything in the common base of something, right? So what we'll do is, first off, we're gonna have to take the log both sides, but before we do that, let's get rid of this 3. We could get rid of 3 by dividing both sides by 3. So this cancels or becomes a 1. So on the left side, you have 2 raised to the x equals 42 over 3, right? Now, like it's 42 over 3, I think that comes out as 14. Yes, it does. So we can rewrite this as 2 to the x equals 14. Now, because you can't get everything in the common base, right? You can't, well, let's try putting everything in the common base of 2. So this is already 2, so you don't have to do anything about this. Oh, what about the 14? Can you rewrite 14 as a common base of 2? No, right? There's no number raised any, there's no 2 to any power will give you 14. It's just impossible. So let's take the log of both sides. So we have a power of x, so we're going to put that in front of the log. So it's going to be x times log of 2 equals log of 14. Okay. And then what you're going to do is you want to solve for x, so you're going to divide both sides by, get rid of this log 2 by dividing both sides by log 2. Dividing both sides by log 2. So you get x equals log 14 divided by log of 2. Okay. And then when you put this in the calculator, you will get exactly about 3.80735. And then they say round to the nearest 3 places, 3 decimals, so tens, the hundredths place, thousandths place. So that would be your 7. And then if you look at the neighbor, is it 5 or greater? No, 3 is not greater than 5. So your final answer is going to be x is going to be about 3.807. Okay, let's do example 5. Let's see, it says solve and round to 3 decimal places. So how would you do this one? So we want to solve for t. So first thing I would do is so we have 2 parentheses raised, 2 parentheses 3 raised to 2t minus 5 parentheses minus 4 equals 11. So the first thing I would do to get solve for t, right, is move this 4 to the right. So you're going to add 4. And then over here we have 2, 3, and then it's still 2t minus 5 parentheses equals 11 plus 4 is 15, right? 11 plus 4 is 15. And then next thing I would do is to solve for t, I would get rid of this 2. And since this is multiplication, the opposite of multiplication is dividing. So you will get this cancels. So you're left on the left side, you're left with 3 raised to the 2t minus 5 equals 15 over 2 is, I don't know if it comes out evenly. It's just, yeah, it comes out as 7.5. So I'll keep it as 7.5 because the decimal doesn't keep on going forever. So as you can see, there's no way we can have a common base of, there's no way we could put these numbers into a common base. So you're just going to have to take the log of both sides. So this whole thing is a power. So you're going to rewrite this as 2t minus 5 times log of 3 equal, and then on the right side, take the log of the right side. So that would be log of 7.5. Okay, now this on the left side, we have 2t minus 5 log 3. So that's like multiplying. So what you're going to do is FOIL out, you're going to multiply each term by log 3. So that's here would be, when you multiply 2t by log 3, you get 2t log 3. Okay. And then over here, when you multiply the negative 5 by log 3, you're going to get minus 5 log 3 equals log of 7.5. Okay. So our goal is to solve for t. So what I would do next to solve for t is move this negative 5 log 3 to the right by adding 5 log 3, both sides, 5 log 3. So this cancels. So now on the left, you're left with 2t log 3 equals log of 7.5 plus 5 log of 3. And then we're almost there. To solve for t, we have to get rid of this 2, and we have to get rid of this log 3. So the only way to do that is dividing both sides by 2 log 3. Do it on both sides. So this would be 2 log 3. Now, this cancels, so you're just left with t equals log of 7.5 plus 5 log of 3 all over 2 log 3. Okay. Now, when you put this in the calculator, be careful when you put it in the calculator. Can't just put it exactly like this. You have to make sure the whole thing is on parentheses. So put this in parentheses and then put this in parentheses. So when you put that in the calculator, I get t equals about 3.41702. So they say round to 3 decimal places. So t is going to be about 3.417. Okay, so that's how you solve for that t. Let's do example 6. Okay, so it says solve. Now we have e to the 2x minus 3e to the x plus 2 equals 0. So we want to solve for x, right? So honestly, some people could just figure it out that when you could just factor this out, and then this would be e to the x, and then two numbers that are multiplied gives you positive 2, and when added gives you negative 3e to the x. That would be negative 2 and negative 1 equals 0. And then what you can do is set each equation to 0 just because you want to solve for x. So you could do ex minus 2 equals 0. And then ex minus 1 equals to 0. Solve for x, so you're going to add 2. So this is e to the x equals 2. And then over here, you're going to add 1. You get e to the x equals 1. Now, you want to solve for x, but you have to somehow get rid of this e. The only way to do that is take the inverse. So what is the inverse of e, or the exponential graph? Well, the inverse of e is, believe it or not, ln, natural log. So you're going to take the ln of both sides. So over here, when you multiply ln times e to the x, the e and the ln cancel because they're inverses. So you're just left with x. And then on the right side, you're left with ln of 2. Okay. Now let's do the same thing with here. Get rid of the e by multiplying both sides by ln. So ln times e is just x, and then this is going to be ln of 1. Okay. Now ln of 1, what is that? That's actually a number. That's going to be 0. Okay, so we have two possibilities, and when I say two possibilities, sometimes you will have an extraneous solution, meaning one will not work or none will work. So you're going to have to check it. So let's check the easy one, the 0, x equals 0. So what you're going to do is put wherever you see it, you're going to plug it back into the original problem, right here, and then just replace x with the 0. So that would be e 2 times 0 minus 3e times 0 plus 2. Okay, so e to the 2 times 0, that's e to the 0, and then this is minus 3e to the 0 plus 2. Does this equal to 0? Let's see. E to the 0, what is that going to be? Anything raised to the 0 is 1. And then over here is minus 3 times e to the 0, so that's minus 3 plus 2. So 1 minus 3 is negative 2 plus 2 equals to 0. this cancels, so 0 equals 0. That statement is true. So we can conclude that x equals 0. Okay, now let's I don't have much space, so let me erase this part right here if you don't mind. I'm going to check with ln of 2. So we check that x equals 0 is a true statement, so that is one of our solutions. Now let's try ln of 2. I'm not going to use the decimal value of ln 2, I'm just going to use exact. Okay, so it's going to be e2 times ln of 2 minus 3e ln of 2 plus 2. Is that equal to 0? Okay, so over here, e and the ln of 2 cancels, right? So what I'm saying is e and the ln cancel, so you're just left with 2 and 2, which is 4. And then over here, the e and the ln cancels because they're inverses, so you're left with a 2. And then you're going to times that by -3, which is -6, right? -3 times positive 2 is -6, plus 2 equals to 0. So 4 minus 6 is -2 plus 2 equals to 0. So 0 equals 0. The statement is true. So we can conclude that x equals ln of 2 is a solution. Okay. They both work, so that's good. Okay, let's move on. Okay, on example 7a, they want you to solve. So this one's not actually, this is actually an easy one. We have ln of x equals 2. So we want to solve for x. So how do we do that? Let's get rid of the ln. And the only way to get rid of the ln is multiplying both sides by the inverse, right? And we know the inverse of ln is e. So you're going to take e to the both sides. So e times ln of x, well, these cancel because they're inverses. So you're just left with x equals, and then it's going to be e raised to the second power. Okay. And that's it. That's your answer. X equals e to the second. Okay, let's do B. It says solve. We have log base 3 of 5x minus 1 equals log base 3 of x plus 7. So this is actually a good one because what do you see on the right and left? They both have a common base of log 3, right? That's a good sign because remember, if you have a common base, you could ignore the base and then just bring down the power. So you have 5x minus 1 equals to x plus 7, right? So now we just got to solve for x. So I'm going to add 1. You get 5x equals to x plus 8. And then what you're going to do is subtract x. Subtract x, you get 5x minus 1x is 4x equals to 8. Divide this by 4. You get x equals 2. And that may be our solution, it may not be. So the only way to check it is by plugging it back into the original problem. So let me go ahead and check it. So that would be log base 3. And then wherever you see an x, plug in 2. So that's 5 times 2 minus 1 equals log base 3 of 2 plus 7. So it's going to be log base 3. And then 5 times 2 is 10 minus 1, that's 9, equals log base 3 of 2 plus 7 is 9. So I don't even have to, we have on the left side, we have log base 3 of 9, log base 3 of 9. You don't even have to cancel log base 3 because they're pretty much the same thing. So this statement is true, so we can conclude that x equals 2. Okay, let's move on to how much? 3 more examples. Okay, so we have example 8, solve for x. So we have 5 plus 2 ln of x equals 4. So what I'm going to do is subtract 5, get 2 ln of x equals 4 minus 5 is -1. Then the next step I would do is get rid of this 2. And since this is multiplication, the opposite of multiplication is dividing. So we get ln of x equals to -1/2, right? So now we want to solve for x. So I have to get rid of this ln to get solve for x. So the only way to get rid of the ln is raising everything to the e power, because ln and e are inverses. So over here, these cancels. You're just left with x on the left side. And then on the right side, you have e to the -1/2. Okay. And then if you want, that's about 0.607 and rounded to 3 decimal places. Okay. Let's move on. We have 2 more examples, then we're done. So let's do example 9. We have 2 log base 5 of 3x equals 4. So the first thing I would do is get rid of this 2 by dividing both sides by 2. So we have log base 5 of 3x equals 4 divided by 2 is 2. Okay, so this is weird to look at. We have log base 5 of 3x equals 2, and you're probably thinking, well, how on earth do I solve for x? Usually you could take the e, right? But it only works for natural log. We don't have a natural log. We have log base 5. So what I'm going to do is write this rule, this log rule. So you've probably seen this somewhere during lecture or on your notes. This is one of the log rules. So we have y equals log base a of x if and only if, and only if a to the y equals x. Okay, so let's look at our problem very carefully. We have log base 5 of 3x equals 2. Well, I know this equation, this entire equation, looks very similar to the left, right? So that means we have to convert this into power form. And when we do that, we got to find our base, our a, our y, and our x. Well, my base is 5. My y is always always the number on the right or left side of the equal signs. In our case, our y will be 2. And then our x is the one in the parentheses. So our x is just 3x. So it's going to be a to the y equals x. So our base is 5. My y is 2. And my x is 3x, right? Okay, so 5 squared is 25 equals to 3x. Then what you're going to do is divide both sides by 3. So you get 25 over 3 is, we'll just keep it as 25 over 3 because it's like a very long number, a repeating decimal. So we'll just say 25 over 3 right now. Okay, so does that mean that is our solution? We don't know. We got to check it, right? So go ahead and check it by plugging it back into the original problem. So what was our original problem? It was right. It's 2 log 5 of 3 of x. Actually, you could put it here or here. It doesn't matter. So I'll put it into the second part. So it's going to be log base 5, 3 times 25 over 3, parentheses equals to 2. So the 3's cancel, so you're left with log base 5 of 25 equals to 2, right? Now remember in power form, it is like the left side. So this is equivalent to saying 5 to the second power equals 25, right? Now is that statement true? Yes, 25 equals 25. So we can say that x equals 25 over 3. Okay, let's do example 10. We have solve log base 10 of 5x plus log base 10 of x minus 2 equals. We have, this is our last one. Yeah. is our last one. So we have log base 10 of 5x plus log base 10 of x minus 1 equals 2. Okay, so the first thing I would do is actually simplify the left side. Let's condense it into one single log base 10. So we can do that. So that'd be log base 10. And then we have an addition. So what do we know about that? When you're adding logs, you're really multiplying. So this would be 5x times x minus 1 equals 2. And when you simplify this, is going to be log base 10. And then when you FOIL this out, 5x times x minus 1, you're going to get 5x squared minus 5x equals to 2. Okay. Now we're going to put it in, we're going to use the power rule, right? It is in, so when I'm going to write it again, y equals log base of a of x if and only if a to the y equals x. So our equation looks like this side. We just got to put it in power form, a to the y equals x. So we got to find our base. Our base is, or a is 10. My y is always on the right or left side of the equal sign. So in our case, it would be 2. And our x is going to be 5x squared minus 5x. Okay, so let's do that. So it's going to be 10 to the y equals x, which is this whole thing, 5x squared minus 5x. And then 10 squared is 100. 5x squared minus 5x. You want to solve for x, so we have to factor. And in order to do that, we got to get 1 times 0. So let's subtract 0. So you get 0 equals 5x squared minus 5x minus 100. And then what you want to do is solve for x. So you want to solve for x, so you're probably going to factor, but before that, I'm going to get rid of these 5s by dividing everything by 5, right? So this would be 0 equals x squared. And then negative 5x over 5x is negative x. Minus 100 over 5 is negative 20. Okay, so this would factor nicely. We have x, and then I need two numbers multiplied to give me negative 20. And when added, gives me negative 1. I'll definitely use 5 and 4. And then I'll use negative 5 plus 4 equals 0. And then we have our 2x value equals 5. And x equals negative 4, right? Because when you solve for x, you get negative 4. So we have two possibilities. We got to check for extraneous solution. If you go back, you're going to have to plug each problem into the original problem, right? Or, yeah. So I know you can either put it back to the original one or this one right here. So there's actually one you can actually cancel. You can cancel negative 4 because if you put it back into the original one, if you plug in x right here, you would get negative 5 times negative 4 is negative 20. And you can never have log base of 10 of negative 20, right? You can never have a negative inside the parentheses. So that will never work. So we can eliminate negative 4. So now let's plug in 5, put it back into this one. So we have log base 10, and then wherever you see an x, plug in 5. So that would be 5 squared, which is 25. Wait, 5 squared is 25 times 5, which is 125, minus negative 5 times 5 is 25 equals to 2. So we have log base 10 of 125 minus 25, that's 100, equals to 2. And then this is like equivalent to saying the power rule, right? A to the y equals x. So it's like saying 10 to the second equals 100. Is this statement true? 100 equals to 100? Yes. That's so true. And then we can conclude that x equals 5. Okay. I guess that's it. That wraps it up for this section. Okay, you have a great day. Thanks. Bye-bye.